Hey everyone, welcome to another video. Today we are moving on from what we've done with simplifying fractions to going to looking at trying to perform operations with algebraic fractions, which is particularly in this video, multiplying and dividing. Now, I'm guessing by the time we've gotten to this video, if you've watched the previous series, I'm recording this video assuming you know how to factorize as well as you know how to factorize and simplify algebraic fractions too, as well as perform some regular operations with fractions like multiplication and division here. So some of the explanations are going to be a bit quicker for this video because I'm more concerned with applying the things we know about factorization to multiplying and dividing algebraic fractions rather than the actual multiplying and dividing, the things you would have done a couple of years ago for fractions. So we'll jump straight into some examples here. And I have this big messy question up here. Now I've said in the previous video that the great thing about any fractions when we simplify is that no matter how many algebraic terms, how many binomials, how many binomial products we add to this, the same principles still apply, which is that any of these crazy looking questions, we can still apply everything we know from our regular understanding of fractions back in year 7. So when we do these types of questions, I urge all of you to go with a simplification first strategy if possible. When we have things like this, it is going to be a massive pain to expand this, for example, or to expand this or this. And it's kind of pointless because in order to multiply or divide fractions, they involve multiplying the numerators together, the denominators together, but also this factorized form we're already given in the question allows us to make the simplifications beforehand, use the things we learnt in the previous video. So if we jump straight into this, I'm going to be, anytime I attempt a question like this, looking at where can I simplify? What do I have the same in top and bottom? Now, what's important to note is that even though these are written as separate fractions, we can simplify diagonally. So for example, we can simplify things up here with things down here as well, because this whole thing is kind of the same as just writing, as expressing this as something like this. We just put the separate fractions in to make it easier to digest. Okay, so now let's look at trying to simplify first. Before we even do any multiplication, we're going to try to simplify. So I have an x minus 1 up here, and I have one that's going to cancel with another down here. I have an x minus 2 on this denominator, and that can also cancel with this one up here. Now that I've done this, it already looks a lot neater. So let me rewrite this again. So I have now just 3 times 4 on the numerator, which, because everything else has cancelled out, I can rewrite that as 12. Because remember, when we multiply fractions, the numerators multiply and the denominators multiply. But the one down here is just 1. This is 1 as well, so they contribute nothing. So we can just write, all that is left down the bottom is 9 outside of x minus 7. And now all there's left to do is to think, well, can we simplify further? Well, I know that there is a number that goes into 9 and 12. So this is the number 3. So this I can almost write as well as 3 times 4 on top of 3 times 3 outside of x minus 7. And these two, because I have the same factor top and bottom, these 3's will cancel out. They'll cancel out to 1. So all that is left to do is to just express this without the 3 on 3 because they cancel each other out. So I'm left with 4 on top of 3 outside of x minus 7. Once again, before we even did any multiplication, think about it, the only multiplication we really did here was 3 times 4. That's how easy you can make this for yourself if you approach a simplification first strategy. The stuff here is already factorized. So we just need to look at these factors and see where we can cancel out. Now, we have this question here. I have this expression on the left, this fraction dividing by the other one. Now, you may remember from year 7 fractions that when we are dividing by a fraction, it is the same as multiplying by its reciprocal. So I'm rewriting this on the left-hand side because that doesn't change. And to make this easier for us, I can write this as multiplying by the reciprocal, x plus 7 on top of 3 outside of x plus 4. Now that I have this, now that I have a multiplication, all I want to do is now think about simplifying. I always want to try to simplify first. So here I notice that I have an x plus 4 up here. That's going to cancel with this x plus 4 on the bottom. I have a x plus 7, and I also have a x plus 7 up here. Oh, sorry. Oh no, that's okay. Thought I made a mistake. Now that I have this, I can rewrite this, and you can see just by simplifying, this is going to look a lot neater now. So I have this, and on the bottom I have x times 3. Now all that's left to do is just multiply x by 3. So I get left with x minus 3 on top of 3x. Once again, although this is a multiplication or a division question, but we just rewrote this as a multiplication with a reciprocal, there wasn't actually any multiplying of any of these algebraic expressions. We didn't have to. We saved ourselves from having to do that by simplifying, so that all that was left to in terms of multiplication was this thing down here, x by 3. That gives us 3x on the bottom and x minus 3 on the top. Now we're going to move to the very last question in this video, which is a little bit trickier. Why? Because we are going to need to do some factorizing. You can see here, here, and possibly even up here. We have plenty of opportunities to think about factorizing. So I'm going to factorize each of these things separately. So x squared minus 4. A similar example to this came up in a previous video. Now this, if you've noticed, this is a type of quadratic expression, but it is a difference of 2 squares. And every time we have a difference of 2 squares, we can write that as, we can factorize it as a binomial product with the square root of each of the terms, because both x squared and 4 are what we call perfect squares. And there's a minus between them, so it's a difference of 2 squares. There are 2 numbers that multiply to give us both of these terms. That's how we know they are perfect square numbers. So my x is going to go here, and remember my signs in the 2 brackets are going to be opposite, because those middle terms, these x's, are going to cancel themselves out. and that's going to leave us with x plus 2, x minus 2 over here. So that is this first thing written as a factorized, written in factorized form. We're going to do the same for 5x plus 5, because right now it's not allowing us to really do anything with it. So we want to write this in a factorized form to see if we have these products in the numerator that we can possibly cancel out with terms on the bottom or numbers on the bottom. So the common factor to 5x and 5 is just 5. How many times does 5 go into 5x? It goes x times. How many times does 5 go into 5? It goes 1 time. And finally, I want to do this in another color, and it might take a little longer. I want to factorize x squared minus x minus 2. And here I want to state the product, which is negative 2, the sum, which is negative 1, because negative 1 is the coefficient in front of this x, and I want to pick my factors. Now, the product is negative, so that means that one of these numbers is going to be positive, one of the factors is going to be negative. So 2 is a prime number, so, sorry, negative 2 is a prime number. So we just want to, well, we're only going to have 2 sets of factors with these negatives happening. We have negative 1 and 2, and negative 2 and 1. So if I add negative 1 with 2, that gives me positive 1. So it's not going to be this one. But doing negative 2 plus 1 gives me negative 1. So it's going to be this one here. So now I can write in that my factors are negative 2, 1. Now let's get to factorizing. So this thing here, I can write it as x squared, and I'm going to break this negative x up into minus 2x plus x minus 2, and I'm going to group in pairs again. It's the same stuff that we've been doing this whole series. X squared minus 2x, the common factor is x, and in my brackets I will have x minus 2, and my other thing here, I just have regular x minus 2. So I can write that as 1 outside of x minus 2. And here, I just want to find, now that I have a binomial factors to both of these, I can pull that common factor out. So I'm pulling out x minus 2, and in my brackets, I'm left with x plus 1. Now, it took a lot of work. And some of you may be thinking, well, this is a lot of work to do. I've just had to break up each of these things into factorized form. But look what happens when I write these new factorized forms into my old fraction. So I have, instead of x squared minus 4, I have x plus 2, x minus 2 over 25, and that's getting multiplied by 5 outside of x plus 1, and over here I'm going to get x minus 2, x plus 1. Now look how much easier it is to work with. I can simplify way easier now. I have x minus 2 up here, x minus 2 down here. I have x plus 1 up here, x plus 1 down here. I can now think about cancelling. And all I have to do now is multiply. Well, there's nothing for this denominator to multiply, it's just multiplying by 1. So we're still going to get 25 down the bottom. And on the top, my x minus 2 is going to multiply by 5. So I get 5 outside of x plus 2. And now I can see finally that I have a number. If we look at my whole numbers now, because there's nothing more we can do with x plus 2, my 5 and 25, I have a number that goes into both of those, and that is 5. 5 goes into 5 one time, and that cancels out with the 5 on the bottom, because 5 goes into 25 5 times. And here, 1 times x plus 2 over 5, I can just simplify that and write it as x plus 2 over 5. And that is my final simplified answer. You can see once we know how to factorize and we take a factorization first, simplification first approach, it makes a question like this, which looks really hard, it breaks it down into something far easier to work with once we do the factorizations. And most of the questions in your textbooks where you're learning from, they're going to make these nice for you. So you will likely end up with a really nice answer, but you have to do the factorization and simplification first. That way you're putting yourself in the best position to make the actual multiplication or division really easy. In all of these examples, in terms of the actual operations, multiplication or division, we only really did these once because we simplified first. Thank you so much for watching, guys. I'll see you in the next video.